Assalamu alaikum everyone. This is Syeda Minhal Bukhari, and today I'm gonna give you a lecture on a certain topic which I have selected. And let me introduce myself. I have I am pursuing my bachelor's in electrical engineering from NAD University. I have done my matriculation from Metropolis Girls School. I have done my intermediate from PCHS College, and I have done multiple courses in robotics, and I have served as a co-director in robotics team in Centec Society. I have already served as a volunteer in a summer fundraising campaign of Saya Foundation. I was a runner-up at second position in whole Pakistan's intra science essay writing competition, and I have done multiple courses in regarding my field work. I have experience over a lot of softwares related to my field, related to electrical engineering. I have presented my paper in the fourth International Electrical Engineering Conference, and I have done the Famul Quran course from Aluda International. I think this is all about me. Let us move to the main slide. That is our topic. Okay, so this is our topic for today. The chapter or the lecture named as chemical bonding. It also includes the classification, that is the intermolecular and the intramolecular bonding or attractive forces. It refers to the chapter number 4, chemical bonding of first year HSC part 1. And it also refers to some of the topics that we have already included or that we have already studied in SSC Part 1 9 class. So it is beneficial for all the students who are interested in chemistry and who are interested in the depth of the chemistry topics. So let me start it. These are the learning outcomes which I am sure that you will be able to understand all of these and learn all of the concepts that I have written. First is the chemical bonding concept. Number two, you will be able to understand the difference between the intermolecular and the intramolecular with their examples. You will be understanding ionic bonding in details, and you will be learning about the covalent bonding together with its type and its formation and the properties of the chemical compounds. Here, the first definition that we are going through is the definition of the chemical bonding, that it belongs to the attractive forces which hold the atoms together in a molecule is called chemical bonding. And it also refers to the binding force which atom requires to make bonds with other atoms in a molecule or a compound. First, we can see what is the basic difference between the molecule or a compound. The molecule or a compound is being regarded as a molecule can be defined as it contains the atoms of the same element, or a compound is being regarded as it contains the atoms of the different elements. So we should know the difference between these both. Okay, now coming to the next slide. The next slide surely is the being the multiple questions that is arising in your mind, that why we should do chemical bonding, or what causes the atoms to do the chemical bonding, or why do atoms take part in the bonding. So here I am gonna give you the reasons. Okay, the number one reasons that the atoms is being participating together in a chemical bond is due to their electronic configuration in their valence shell. What is the valence shell? Valence shell is the last shell that is being made in the atomic structure of the element, and to fulfill the octet rule given by G.N. Lewis in 1916. So what is this octet rule? This octet rule is being defined as that An element with 8 electrons in the valence shell or in the last shell is most stabilized or is the most stable. So, what do you mean by stable? Any person who is in any phase of his life always wants to make him stabilize by gaining reputation or by gaining knowledge in the society or by posting to the higher designations. Same goes with the atom that an atom wants 8 electrons in the last shell to get stabilized, but these in the picture right to it, it is mentioned that k electrons always occupy the 2 electrons. That is the most stabilized form of it, and the L shell occupies the 8 electron that follows the octet rule. But the M and N shell contains the 18 and 32 electrons. These this is according to the electronic configuration given. But according to GN levels, only that atom will be stable that is following the octet rule. So to follow the octet rule, the atoms does exhibit the chemical bonding. Okay. Here are some examples, or here are some examples by which you can see the atomic structure with the configuration of the electrons in the specific shells. The first shell always contains, if you go through the lithium, the first shell contains the 2 electrons in the first shell. The L shell contain 1 electron because of the atomic number that is being denoted by Z is equal to 3. Then the number of electrons or protons in sodium is called the atomic number. It is 11 here, and it is being arranged in the 2, 8, and 1 configuration. Like first shell contain 2 electrons, the second contain the 8 electrons, and the last one contains the 1 electron. Same goes with aluminium, that when you realize and when you go through it, you will learn about the atomic structure and the electronic configuration easily. Now, I am coming to another slide, that is the classification of the chemical bonding, that is the intramolecular and the intermolecular bonding forces. So, what does it mean by the intramolecular or the intermolecular? We will discuss it later. Okay. Here, intramolecular bonds or forces are being defined, and the definition is the forces of attraction that exist within a molecule. We know that atoms combine themselves to form a molecule, and the bond which is enabling them to be combined together, the bond that exists within that atoms to form a molecule is known as the intramolecular bonds or the forces. So examples are the ionic bonding, covalent bonding, and the coordinate covalent bonding, that is also known as the dative bonding. Okay, let's move us to the another type. Okay, the second type is the intermolecular attraction, the intermolecular bonds, or the intermolecular forces that exist between the molecules. So, what is the basic difference between and within? Between means that one molecule is already formed and the other molecule is already formed, and these both are held together by the intermolecular attraction. So, the forces that act between the neighboring particles. It may be ions, it may be molecules, it may be atoms. These are known as the intermolecular attraction bonds or forces. So, these intermolecular attraction are weak as compared to the intramolecular forces, which is rather more stronger than it. Okay. Now, the examples of the intermolecular attraction that we will discuss if we have time: hydrogen bonding, dipole-dipole interaction, London forces, that is also called the dispersion forces, and the last one is the van der Waals forces, that is the most weakest. Okay, here a small picture is showing you about the specific hydrogen, chlorine, hydrogen, chlorine, hydrogen, chlorine. This is the element of hydrogen. This is another chlorine, hydrogen, chlorine. The one atom of element and the other atom of element are being held together by a thread and a needle. By thread and a needle is acting as a intramolecular forces here, and we have used a velcro. Velcro means it is a, we can say that it is an elastic medium which can stick them together, but the velcro is being acted as a intermolecular attractive forces. Why? Because it is having the HCl molecule together. So one molecule when combined with the other molecule, the forces that is gray here is acting as a intramolecular forces. Okay. Now, okay. So here clearly you can understand the intermolecular attraction and the intramolecular attraction that is I have been explained in the previous slide. Okay, coming to the next one. Now we are discussing the most important type of the intramolecular bonding or attractive forces, which is ionic bonding, and is also called as the electrovalent bonding, that is being introduced by the Swanti August Arrhenius. This is the type of the intramolecular bonding which is formed due to the gain or loss of electrons. Here we can say that gain and loss of electrons is another, in another terms, can be called as the complete transfer of electrons. So here I am discussing the necessary conditions that is required for the ionic bonding. Number one is the low ionization potential of the electropositive atom. Number two is the high electron affinity of electronegative atom. And number third is the high lattice energy. Number four is the small internuclear distance. So, what do you mean by the term ionization potential, and what do you mean by other terms that is difficult? Number one, I am defining the electropositive atom and electronegative atom. Electropositive atom are those who are willing to lose their electrons, and they may be regarded as metals that belong to the group 1A, 2A, and 3A of the periodic table. Okay. Electronegative atoms are those who are willing to gain electrons, who are being attracted to gain electrons, and they may be regarded as non-metals or sometimes metalloids. So, all the non-metals are referring to the group 5A, 6A, and 7A of the periodic table. Now, number three condition is the high lattice energy. First of all, we should learn about what is lattice. Lattice stands for, in other words, crystallization, or we can say that crystal. The arrangement of a definite pattern in which the ions form the closed shape or the 3D shape in which they are held together by some intermolecular forces is known as lattice or crystal lattice. So, what is lattice energy? Lattice energy is the energy that is being absorbed or that is being released when ions make their crystal lattice or when ions break their crystal lattice. It all depends when they are making their crystal lattice, the high amount of energy is required. So we can say that high lattice energy is required in order of that it is an endothermic reaction that it will absorb the heat energy. But when we are talking about the high lattice energy, in order to break the crystal, so in order to break the crystal, the high lattice energy is released. It means it is an exothermic reaction. Okay. Number four is the small internuclear distance. Internuclear distance is being regarded as the distance that is measured between the two atoms. I am clearly showing it on here. Let's suppose we have the two atoms, number one and number two close to it, and they have the nucleus in between them. So the average distance between the two nuclei is known as the in small inter is known as the intermolecular internuclear distance. The distance between the two nuclei, average distance between the two neighboring atoms. Why it should be small? It should be small because if the atoms are together, they can easily gain or loss of electron. They can easily gain or lose electrons. Now, what is the term IP stands? IP stands IP stands for the minimum amount of energy that is required to lose electrons or to rebond the electrons from the valence shell or from the last shell. So whenever the electropositive atom wants to lose its electron, it should need the minimum amount of energy so that it can easily give its electron to another atom. And what is this meaning of the electron affinity? Electron affinity is the energy change when an electron is gained by the atom. So when the electron is gained by the atom, the word gain means it has a love for electron. So when it has a high love for electron or high attraction of electron, it can easily catch up those electrons and form the bonding by the complete transfer of electrons. I hope it is clear. Now, coming to the next slide. Okay. In this slide here, we are showing the formation of the ionic bonding in NaCl. We know that Na sodium, Cl is chlorine. Sodium belongs to the group 1A, that is electropositive. Chlorine belongs to the group 7th A, which is highly electronegative. It means sodium has the low IP and it is very willingly to lose its electron, and chlorine is highly electronegative and it has a greater love for electrons, so it can easily lose its one electron. But why sodium is losing its electron? Sodium is losing its electron to complete the octet, and chlorine is attracting the electron to complete its octet. So whenever a electron or an electron is being loosed by an atom, it gets a positive charge and it is being called as a cation. And whenever an atom gain the electron towards itself, it is being regarded as negatively charged, and the negatively charged atom is now called as the anion. So here in the downward picture, we can also resemblance the both pictures that whenever the sodium donate electrons, chlorine accepts electrons, and the bond that shares between them is known as the ionic bonding or the electrovalent bonding. Here are some other examples of the ionic bonding of the ionic compounds: magnesium oxide, sodium fluoride, calcium chloride, potassium oxalfide. Now, here I am describing the properties of the ionic compounds in which the ionic bond is being formed. Number one, they are generally hard solids having the high melting and boiling point. We know that why they are hard solid, because their all ions are packed together by the intermolecular forces in a crystal lattice, and they require the high lattice energy to form it. So they are generally hard solids, they are rigid, they have the high melting and boiling point. And ionic substances conduct electricity in solution, fused, and molten state. What do you mean by the molten state? Molten state means in the solution form, as we know that NaCl in the solution form or in water is known as the brine. So in brine, NaCl can form the air ions or ionizes themselves and conduct electricity. Why they're conducting electricity? Because electricity is the flow of ions, and whenever there is a Na plus and Cl minus ion, it can easily conduct electricity, and flow of electrons is called electricity. Number three, they are brittle and they can be broken out into pieces. And number four, they can form crystals of definite shape and size. We have already discussed this point. Okay. So students, another topic or another slide contains the topic covalent bonding. And covalent can be defined as the type of the intramolecular attractive forces that form due to the mutual participation of the electron pairs from atoms of the element. Here I have used a new word, mutual participation. So mutual participation means the mutual sharing of electron pair between the two atoms. And this idea was first introduced by G.N. Lewis in 1916. And the necessary conditions required for the covalent bonding is the high ionization potential. Why high ionization potential? Because the energy required to take the electron out needs to be more, so that we need the more energy. We need the equal electron affinity, and we need the high nuclear charge. Why we need the high nuclear charge? Because the high nuclear charge means proton in the nucleus have the greater hold on all the electrons on its in its atom, and it can never lose its electron, only just it share its electron. So what do you mean by equal electron affinity? Equal electron affinity means both the atoms that are participating in the covalent bonding must have the equal love for the electrons, so that they can not lose or gain the electrons, but they can eventually share the electron pair between the two. When one of the atom needs the electron pair, it will be revolving in that orbit, and when the other atom needs the electron pair, it will be revolving in that. So both of them are participating in the mutual sharing. Now, here are some examples of the formation of the bonds in covalent compounds. Covalent compounds, here the example of the oxygen makes a double covalent bond. Double covalent bond means it shares the two electron pair. Shares the two electron pair means it needs two electrons to complete their outermost shell. And hydrogen gives us one electron, and other hydrogen gives another electron. So it will be making H2O, and the covalent bond formation. Now the other example is also of the double covalent bond, in which the oxygen not donates, share the two electron pairs together, because one of the electron atom of the oxygen needs 8 electrons in their last shell. Another also needs the 8 electrons in their last shell. So both needs to share the electron pairs together in order to form the double covalent bond. So what do you mean by the double or single covalent bonds? I am sharing it, or I am explaining it in the next slide. Now, we are considering the types of the covalent bonds. Here are the three types of the covalent bond on the basis of the shared pair of electrons. The number one is the single covalent bond, number two is the double covalent bond, and number three is the triple covalent bond. Now, here are the representation of the single covalent bond and the definition also, that it will be forming when only one pair of electron is being shared by the two atoms of element, example HCl and chlorine, that they share the one electron pair together. Okay. The other example is of the double covalent bond, and double covalent bond means it is being denoted by the two short lines, and the example which includes the double bond makes its ethene, and the other is the oxygen molecule, as we have discussed earlier. The number three is the triple covalent bond. As triple stands for three, it means when three covalent bonds are being formed by sharing of three electron pairs between the two elements. Example, here we have given the example of ethine, and number two is nitrogen, because nitrogen needs three electrons to complete its octet together, and it is being denoted by three short lines. These are the types of the covalent bond according to the shared pairs. Now, the another type of the covalent bond is on the type of the atoms that are being participating in the mutual sharing. So number one is the non-polar covalent bonds, that is formed between the two same atoms, so that their electronegativity difference is zero, and they can equally attract the bonding pair between them, so no polarity is found. No polarity means they cannot gain any type of the charge, because they are not losing or not seizing the electrons. They are mutually sharing the electrons, and they both have the same they both are the same atoms. It means they have the same electron affinity, same electronegativity, and same IP. What do you mean by electronegativity? Electronegativity is being defined as the tendency to attract the shared pair of electrons towards itself. So they both have the same tendency. So the difference of the electronegativity is being zero. As we know that the electronegativity of hydrogen is 2.1. So 2.1 minus 2.1 will be 0 when it forms the non-polar covalent bond. And when we come to the polar covalent bond means the atoms share the bonding pair unequally. It means one can C is greater than the other. Both have the different electronegativity values, means they can be differ in their attracting. So here are the examples of HCl and HF because they both are formed between the different elements and different atoms. Now, now I am discussing the properties of the covalent compounds. Covalent compounds may be gases or liquids. Why they are gases or liquids? Because they cannot form the crystal lattice. They have not the strong intermolecular bonds, so that they are soft in nature. Their melting and boiling point are too low, and there are the poor conductor of electricity in fused form. Why they are called as the poor conductor of electricity? Because they cannot be broken down into ions in the fused state or in the melted state, because they both attract the electrons equally, or they have the same electron affinity between the both atoms of elements. Okay, number last is they are rigid and they exhibit isomerism. So what do you mean by isomerism? Covalent compounds can exhibit isomerism. Isomerism is being divided into three syllables. Iso means same, mer means unit, and ism means procedure. So the procedure in which a compound which is of the same chemical properties is being divided into different physical forms, or we can say that a compound which is found in different shapes and sizes and in different colors, having the different physical properties but same chemical properties. I am quoting the example of carbon here, which is found in nature as diamond, different physical property, as graphite, different physical property, and as buckyball, different physical properties and shape. But they all are actually carbon atoms and hydrogen atoms being combined with one another. Okay, okay. At last, these all are the reference from where I have taken the text and I have taken the pictures to make you understand the lectures. So if you want to have those pictures, you can be proceeding towards these URL websites. Now that's here from my side. I hope all is clear from my side and you all are able to understand the basic concepts of chemical bonding. Thank you so much. Allah Hafiz.